Assalamualaikum warahmatullahi wabarakatuh and hi to everyone. So in this video, I will talk about chemical equilibrium. So in this chapter, we will learn about dynamic equilibrium, equilibrium constants and Le Chatelier's principle. But in this video, I will just include Le Chatelier's principle for your more understanding in this chapter. What is Le Chatelier's principle? Le Chatelier's principle states that when chemical system is disturbed, it retains equilibrium by undergoing a net reaction that reduces the effect of disturbance. It's just like seesaw. There are three kinds of disturbance, which are change in concentration, change in pressure, and change in temperature. Firstly, let's take a look at the change in concentration, assuming A is reactant and B is product. The reaction is equilibrium at first. Then, we put disturbance by increasing concentration of A. The reaction will favor to the right. So, the reaction becomes not equilibrium. We have to encounter A back and make the reaction move to the left to make it equilibrium again. Next, move to the change in pressure. By ideal gas law equation, we know that when the pressure is increased, the volume will decrease. This diagram will help you more understand about this equation. Pressure changes can occur in three ways, which are changing concentration of gases component, adding inert gas, and changing the volume of the reaction vessel. Assuming A plus B is reactant and C is the product, then we add disturbance by decreasing the volume. When the volume decreases, the pressure will be increased. There are 2 moles of gas in the reactant and 1 mole of gas in the product. So, the reactions are not equilibrium. To decrease the pressure, the high molecule will move to the low molecule to reduce the number of gas molecules. So, the reaction will move to the right to make the pressure of reactant decrease, the volume of the reactant are also increased, and the reaction will become equilibrium. Lastly, we will look at the changes in temperature. Only temperature changes can alter K. To see how this will affect the equilibrium, we have to see whether this reaction is exothermic or endothermic. This tells us whether this reaction absorbs energy or releases energy, and this signifies by the delta H. If the delta H is negative, the reaction is exothermic and releases energy, so we can think heat energy as the product. And if the delta H is positive, the reaction is endothermic. Energy must be absorbed for the reaction to go, so we could think that heat energy as a reactant. When the temperature increases, the heat energy are also increased, so heat will shift to the other side to use up some excess heat. Cooling down would have the opposite effect. Then, we assuming A plus B is reactant and C are the product. Then we put the disturbance, which are rising in temperature. When temperature is increased, the heat are also increased, and that is exothermic reaction. In exothermic reaction, we can think heat energy as the product. The reaction will move to the left to encounter back the heat, so the heat on the product will decrease until this reaction achieves equilibrium temperature. So, this is the summary of Le Chatelier's principle. You can stop this video to look at it. Thank you guys for watching this video. Bye!